all doing? You're welcome to Next Gen today. I'll just adjust this so you can all see me. So today we're going to be having a session. This is going to be our first session in September, and we're just going to tell you a little bit about AFB. So AFB is actually started in 2011 in Scotland. It was founded in 2007 in England, and we typically have 4 streams of AFB. We have the Next Gen, which is this, which is for primary school and secondary school pupils. We also have the Transition, which are people who are recent graduates from university going into the real world of professionalism and getting jobs and, you know, becoming who they want to be in future. We also have the Real Projects, which are for professionals currently working, and they talk about different topics. So you can tell your parents if they want to join in. Real Projects, it typically happens online because of the COVID. We also have the Leadership Program. The Leadership Program is focused on higher management, top management professionals in companies, in organizations that are currently working in Aberdeen. So today we're going to be having Araz, and Araz is an AFB member. So just a little bit about Araz. Araz has a Master's of Science in Petroleum Engineering from the University of Aberdeen. He is currently working as a process engineer for PD and MS Group. He's a STEM ambassador, and he's been a really good, consistent STEM ambassador that I can testify at Aberdeen Science Centre. And he's also been an AFB UK Next Gen program member since 2017. Araz loves robotics, anything robotics.
Yeah, Mo.
So he's your guy if you're so interested in robotics. So I'm welcoming Araz, who's going to be talking to us today about the sun, moon, stars, and generally the patterns of apparent motion. You're welcome, Araz.
Great, Mo. Thank you so much. Thanks for your kindness. Yeah, it was a great honor to be part of the AFB and working as like a STEM ambassador, like in AFB Next Gen programs alongside with you and Dr. Reno and the rest of the team. So yeah, today I'm going to talk about like our solar system and give you a quick explanation of like the sun, moon, and their apparent motion. So I chose this topic because it was a bit different, and I could find a nice simulation which can show us so how Earth moves around the sun. So yes. Before I go to the simulation, I just show you one slide about to just describe what is Earth equator and what we are going to see in our simulation. Then during the simulation, I won't say anything, like there would be a lady who is just talking about the different concepts. And in the middle of the simulation, she asks you some questions, which we made it like a poll. I launched the poll. I asked your opinion about it. And then I just choose the most correct answer that you just gave to the poll here on the simulation. So it's going to be you that answering the questions in the simulation. So then after we finish that, then I just show you like 1 or 2 more slides, and then we can just talk about anything you may have been interested in the presentation. So, okay, first of all, let's go for. I'm going to share my screen now. So if you see, this is sun. If you follow my cursor, and this is the sun's rays come to the which is and Earth. So when you're just looking at the Earth, this red line that you see over here is equator, which divides Earth to the top and bottom part of it. So top part of the equator is called Northern Hemisphere, with the United States, UK, or Europe in general, they're all located on top of the equator. And countries like Brazil, like and Australia, these are like the southern hemisphere. And this is a general like idea with, to have about the Earth, go through the simulation. Yeah, and at the end, I will say what is this website, legendsoflearning.com, which you can just make an ID. Your parents can just assign you some lessons, and then you can just follow it yourself. And it's a very good resource to keep you like really like entertained, actually, like in a very good way. It can just teach you different concepts of science and mathematics and engineering.
Planet Earth is a tiny part of a vast universe that has developed over a huge expanse of time. Using observations together with knowledge of physics, the patterns of motion of the objects in the solar system can be described and predicted. This is a model of the Sun, Earth, and Moon. The size and distances are different in reality, but we will use this model to explain certain behaviors and patterns of movement. The Sun emits solar energy. The result of this energy is both warmth and light. Earth rotates around its axis once every 24 hours, one Earth day. How long does it take the Earth to rotate around its axis?
You have 20 seconds to answer this question. Give you 30. All right. Okay. I'm just sharing the results. So you've chosen 24 hours. Let's try it. Yeah. And you can just close the poll for now. For the next one.
Earth's rotation around its axis creates a couple of interesting effects that we can observe. You can see solar energy in form of light moving across the northern and southern hemisphere in the upper two frames. As our position on Earth moves with its rotation, we see the effects of sunrise, daylight, sunset and night sky. The red line on both Earth and the upper frame represents the direction that is our view of the sky from the United States.
Yes, this is light is from United States, but if you see like UK is like a little bit further.
As the Earth rotates, the direction of where we are looking and what we are seeing are changing. Due to Earth's rotation, we also see perceived movement of the stars in the night sky, which is not an effect of Earth's rotation.
Now turn to question 2. Yeah, this is your result. So 14 people out of 17 like stars movement. Uh-oh, no, that wasn't the correct answer. Let's see the second one, the seasons. Yeah, those three were right. Sharing. Move on.
Earth's rotation axis is tilted in regards to the Sun. The tilt changes how much sunlight each part of the Earth receives. Sunlight is most direct around the equator. Temperature falls off towards the poles as sunlight is less direct. As we move from the equator to the poles, what happens with the temperature?
Yeah. Next question. All right. B, it goes down. On 1, it goes up. Right. Goes down is correct.
The Earth-Moon system orbits around the Sun in 365 days. This movement around another object is called revolution. So the Earth revolves around the Sun. During its orbit, Earth's distance to the Sun stays relatively the same. The combination of Earth's orbit around the Sun and its tilted axis creates our seasons. When the northern hemisphere is tilted toward the Sun, it experiences summer. This is because the sun rays strike it more directly. At the same time, the sun rays are not so direct in the southern hemisphere, which causes the southern hemisphere to experience winter. When the northern hemisphere is tilted away from the sun, it experiences winter. This is because the sun rays don't strike it directly. At the same time, the southern hemisphere experiences summer. Notice how different angles of sun rays cause different seasons on Earth. How long does it take Earth to orbit around the Sun once? which two seasons have the most similar solar energy angles?
Spring and autumn is correct.
The Moon's orbital plane is tilted with respect to the plane of the Earth's orbit around the Sun. The Moon orbits Earth approximately once every 27 days. The Moon rotates on its axis at the same rate at which it orbits Earth, so that the side of the Moon that faces Earth remains the same as it orbits. The side of the Moon that faces the Sun is illuminated while the other side stays dark. While orbiting around Earth, we can observe the change in illumination we see on the Moon. You can see all 8 phases of the Moon change in one orbit in the third frame. The Moon orbits Earth approximately once every
Right? Yeah, month. That was easy.
How many phases can we observe in one orbit of the Moon around Earth?
Let's see. This is the last question. I will look for everyone to answer. Okay, 15 is okay. Yep. 8. Good.
Congratulations! Now you know a lot more about the Earth-Moon-Sun system.
Okay. Congratulations for this journey. Hopefully you can hear my voice now. If you can hear my voice, like Martin, shake your head.
Yes, I can. Yes, we.
Right. Okay. See, over. Yeah. So if you see, I want to show you something. Oh, all right. In the simulations, something happened. Like, who can say that? Like, they missed something over there. They haven't talked about it. When we are moving, yeah, in this phase of the moon, yeah, we have the full moon. So the sun, earth, and the moon are aligned together. If you see over here, sometimes,
Not the new moon.
yeah. So if you take a look at the sky, like over here, like in the 27.72 of the day of the year, January 29, you can see the full moon. And also, like, when it goes and moves, and then, yeah, when you stop over here, there will be a new moon. So as the last question, moon has 8 phases, right? It starts from there, waxing first quarter, waxing gibbous, full moon, waning gibbous, third quarter, waning crescent, and new moon. But something that you haven't seen over here is that I'm going to share this. That sometimes something very like a strange happens, like that in so many years ago, people didn't know what is the main reason behind that. So what was the problem? So if you see, like, sometimes we don't see we cannot see the full moon, right? And there would be a shadow in front of the moon. If we take a look at this simulation over here, you will know that what I'm talking about. So that's the main, like, that's the main.
Well, if the sun never existed, then the moon would disappear as it doesn't produce light of its own.
Yeah, look, the main cause is because, like, a moon is not rotating like directly, you know, it has a tilt. So sometimes, like, we see the full moon because, like, because it's not yeah, it's not on this, like, the ecliptic. Sometimes, like, moon starts exactly, moves through and hits the ecliptic, this red line, and that's the time when moon, earth, and sun are in the same path and are aligned. In that time we have the lunar eclipse, right? In many years before, in ancient times, they didn't know why it's happening. So, like, for example, at night, like, they were just standing and moon, it disappear for like few hours, like 1 or 2 hours, and then it comes back, you know, like, and they were just they didn't know why it happened. But today we can see that, like, as the previous, like, slide, see, that's the main star. This is the earth and this is moon. So there's another, like, phenomenon as well, which is called solar eclipse. And this is more important, more interesting, because it happens so rarely, and the fact is, then the basic definition behind it, it's because Earth, Moon, and Sun align together. But we see that, like, Sun is much bigger than Moon, so nothing would happen. But here in this, like, simulation, you can see why it happens. Look, it's because of the distance. Sun distance to Earth is 3 million miles away, but moon distance to Earth is 239,000 miles. All right. So if you take a look at this, yeah, it's because of that. Look, because sun is so far away, its shapes becomes like the size of the moon. And then when we look at the sky in the middle of the day, when we want to see the sun, something comes just in front of it and passes by. Look. And the most important thing about that, and it's like the main concept is the same, you know, like it's just moon that is tilting around the Earth. And then on the ecliptic, on this plane, it just hits the moon. Yeah, and the cool thing about that is, as you see, because the sun is far away and bigger, it causes two different types of shadows on Earth. See, the darker one over here is, which is called umbra, and the bigger one is penumbra. This is the total solar that you can see over here. And for the next one over here, like I want to show you this again. Over here, can you see? This is the point that people on this part of the Earth, they can just experience this solar eclipse as the moon moves around the Earth. And the last slide over here can see the path of the moon. The total solar eclipse happens, you know, like happens on this path. Like for example, on August 21, 2017, it just goes through here. It goes through the North America and comes to the Atlantic Ocean over here. People who were standing on this line, they could see the solar eclipse. Or on 2027, like August 22, it just passes on the top of the Africa and then goes here in the Indian Ocean. Yeah, and the most cool thing about it is it happens once every 400 years. So that's why people, there are some of them called like solar eclipse chaser. They just travel around the world to just see this. And be careful. You cannot look at the sun directly for like more than like few seconds. You really need a double darker like safety glasses to look at the solar eclipse. And the lunar eclipse is much safer. Like you don't need to do to have glasses, but solar eclipse you need that. And so yeah, with these slides, I'm just showing you the solar eclipse and lunar eclipse. I think like everything is kind of covered. So I just pass this slide to Orena and see if any of you have any question about the simulation or about the eclipses that we've just talking about, or if you want to see anything again, we can do that. Hopefully I wasn't like talk too fast in this journey, and hopefully you enjoyed it.
Hi, thank you so much, Aras. That was a fantastic presentation. I trust we all learned one or two things from that. All right. I don't know if we have any questions here today. Just unmute your mic if you've got a question for Aras.
Anyone interested in to become a solar eclipse chaser in the future? Yeah, but like this apparent motion, like the most interesting thing for myself was like how our seasons happen, like how Earth is tilted and how the rays of the sun causes this difference in like the season, in our day and night. And I had always this question, like if moon moves orbits around the Earth, why it's not just happening? Why we don't have solar or lunar eclipse each month? You know, like because it's rotating around the Earth. But the main answer is because moon is tilted.
Okay, Aras, there's a question just now. Why do we have the daylight savings?
Daylight savings.
Why do we have the daylight savings in the UK at different times of the year?
Can you just like ask it in another like way? Like, can you explain it more? Like, what does it mean, daylight savings? Oh, you're on mute.
Rana, you're muted. Rana, you're muted.
All right. So can you explain more about daylight saving time, you know, that occurs in March and October? When we usually change our clock.
All right, okay. When we change our clocks.
Either going forward or backwards, yes.
Yeah, so that the main thing we can just describe that is because, like, if you see like the rotation of sun around the rotation of Earth around the sun is not exactly like 365 days. Sometimes it's a bit less, sometimes, and then after, and also like the rotation of Earth itself, it's not exactly like 24 hours. Sometimes like we have, and so this may cause at the end of the 4 years we have another day added to our calendars. But for changing the time in the day, it can be because of the change of the seasons as well, like also like the change from the northern hemisphere to the southern hemisphere. And yeah, like I don't know if I've just answered your question like directly, because like I just went somewhere else, but like I don't know, is there any other questions?
Okay, there's another question here about the time zones.
Yeah, so like if yeah, what's that?
So the question is, why do we have the different time zones all over the world, like the Pacific time zone, the standard time, the Eastern time, and so on and so forth?
Yeah, I think like for that is like if you know, like we have like a kind of a benchmark on the Greenwich, right? Like it's like goes from here, it's like a line which we call it like the zero time, like that's the Greenwich time that we have. And when that line, that like vertical line, when we move towards the right, it just added 1 or 2 hours like to the main time we have. Like for example, now over here is like 10:01. Like somewhere like in Europe, like in Germany, like in Hamburg right now is like 1 hour like more than us. Like there, it's now over there is now 10:02, and it's because like because of that benchmark we have over there. And also like if you want the main answer in the physics, it's because when we are facing the sun in that correct in that time, when Earth moves, it takes 1 hour to move, and they become in the place that we are standing right now. I don't know if you could deliver it or not. You know, some concept of the physics, astrophysics, is kind of like you really need some kind of the simulation or something like that to describe it. Like and see like everything, like the time that we have. So if you see, like in ancient time, they used, there is one in Aberdeen as well, like beside, if you see that there's a lunar watch, like they use some kind of like sticks, and they just put the stick on the earth, and they could just record the time of the day by the shadow of the sun, right? Like when the sun is just hits the wood and its shadow on the earth, they could say if it's like the morning, or if it's in the afternoon, or if it's in the evening, it's going down, and it's going to the night. So yeah, the concept of time is really interesting, actually. Like I actually suggest for you to read about it more in depth online, because like the knowledge actually I have about astrophysics is my part of my modules in the high school as well. So I may not have that strong background to talk about it very like in depth.
Okay, thank you so much. There's another question here just now.
Mm-hmm.
And the question says, why is it hotter in Spain and cooler in the United Kingdom?
Yeah, that's again about that, like about the thing that we saw together on the simulation. If you notice that it's because like Earth is a bit tilted, and the equator is the line which like we had is over here. Like, let me show you. Over here, if you see, like when sun just its rays emits to the surface of the earth, it emits more directly in this part of the earth, like on the equator. If you see, like there are so many rainforests over here, like the climate is different. And also, like the earth is not this straight perpendicular, like it's like a bit tilted as well. Like when you go up, the intensity of the rays which emits to on the surface of the earth just decreases, and that's why the UK is a bit like colder than Spain, and the country is like like the ones that are located directly on the equator. So if you see, like Spain is a bit downer than UK. UK is over here, if you see, and Spain is down over here. So yeah, that's like a very like interesting actually topic as well. There's another thing that it's very interesting in the position of the Earth and Moon and Sun as well, because like Earth, because of the poles that Earth has, it has a magnetic field. So if you see, like this magnetic fields like just protects us from the rays of the sun, because sun can be dangerous as well. And if you see, like and it's all around this, and it's not very like strong on the poles. That's why sometimes you can see northern lights near the poles of the earth. So if you're sometimes I've heard that from Aberdeen, you can just see them as well, but it's much more clear from Shetland, or like the Iceland is the main place to see them.
Last but not the least, why don't we get to see lots of stars in the skies here in the UK, or Scotland precisely?
Why we can't see them?
Lots of stars.
Yeah, so like you know, like our solar system and also in the galaxy, it's full of stars. You know, like it's our advantage, you know, actually, that we are living in Scotland, and the actually over here the sky is much clearer, that we can see them much bright, you know, like brighter. you know, one factor which is like the light pollution of the main cities that just prevents us to see the stars. But if you go somewhere that there's no light pollution, like I mean, it's more countryside, you can see stars more brightly. And there's a very interesting fact is that like sometimes the star that you see in the sky, it may not be there anymore, and it's just its light, you know, like because the stars are burning in the sky. And the thing that we can see from here, it's the light which travels in the galaxy and arrives to the surface of the Earth. So, and if you see them with some instruments like telescope or something, you can see that they have different colors as well, based on their distance, based on their age, or based on the, you know, like, and then it's kind of a very specific like university degree actually, then you can do and to see using chromatography to see where are they exactly by some very simple calculations. So that's a very interesting topic for the future.
All right. Thank you so much. Thank you, Dr. Aras. I think that's all the questions we have for today.
Mm-hmm.
Yeah, did we all enjoy the talk today? You can unmute your mics.
Yeah, I really enjoyed it.
Yes. We really enjoyed it.
Yeah.
Fantastic. Can we give Aras a round of applause, please?
Thank you.
Thank you so much, Aras. We do appreciate your presentation, and we really had a wonderful time. It was such a big time of fun. Okay. In the next 2 weeks, we're going to have another presentation, another nice STEM presentation, and we will be putting up an advert for that on Eventbrite. So please do register, and then you'll get your Zoom details for the event. I would also like to let you know that for everyone who comes into the meeting, we usually have to tick your names from a list, from the registration list. So if you have a device, please kindly rename yourself using the name you have used for the registration. So rather than us seeing Galaxy 8 on the screen or iPhone, we would prefer to admit you using your real name. For example, Jack Jim, you know, rather than iPhone. All right. So thank you so much, everybody, for being here. We are really glad that you did come, and we wish you a wonderful weekend, and we hope to see you in 2 weeks' time. So thank you so much, everyone.
Bye.
Thank you so much.